Hi, I'm Iain and welcome back to the Northland Workshop. I suppose the sewing machine could be considered the power tool of the sewing world, and while I'm not super familiar with the intricacies of operating this particular power tool, I do know how to use some other power tools, and we're going to use those in order to build this table to house the sewing machine. The table is made out of cherry. It has breadboard ends, tapered legs with traditional mortise and tenon joinery going from the apron rails to the legs. So let's get started building this little cherry sewing machine table. I want to get started by gluing up the top so that way this can be drying while we work on other things. And when picking out boards for the top of a table, you want to pay attention to a few things. First of all, most important thing is how it looks, because the top is the focal point of the table. It's what everybody's going to look at most of the time that they're sitting at a table. Because of that, I want to make sure that I arrange the boards in such a way that the grain matches as well as it can from one board to the next to try and make the glue joints as seamless as possible. The other thing I want to do is try and get the color to be uniform from board to board. And if it has to transition from slightly darker to slightly lighter, it does so in the middle of the board, not drastically at a glue joint. Finally, I want to make sure these glue joints are as tight as possible. As you can see here, there's a gap, and here there's a gap, and if I push it together with a fair amount of pressure, the gap doesn't close up. The clamps can exert a lot more pressure than I can just squeezing it together, and they probably could close up these gaps. But I don't want to take that chance. I want them to be airtight all on their own. To do that, I'm going to pass it over the jointer, but I've taken so much time laying out these boards, I don't want them to get out of order again. So what I'm going to do is draw a big triangle on it. Now, every time I put these boards back together, as long as it still makes that triangle, I know all the boards are in the order they're supposed to be. This is the jointer, and this is what we're going to be using to straighten up those edges. A jointer is nothing more but a motorized plane mounted upside down. You have two cast iron beds, a cutter head that rotates with sharp knives on it, or you can get them with carbide inserts, and a fence that is 90 degrees to the bed. By taking one of the boards and placing it up against the fence and holding it tight up against the fence as I run it through, I'm guaranteed to get a straight, smooth edge that is 90 degrees to whichever face I put up against the fence. Let's try it out. There, that's going to be a nice glue up. I'm in the process of cutting some slots for these little compressed beechwood biscuits. What they're going to do is they're going to make it a whole lot easier to align the top boards in the vertical plane, so that way there's a lot less sanding to do afterwards. The other thing is they're going to add a little bit of reinforcement to the glue joint so it shouldn't separate over time. With a thin layer of glue on both sides of the joint and glue down in the biscuit slots, I can now go ahead and glue up the top. I like to alternate the clamps over and under the workpiece to minimize the amount of cupping that might be introduced by clamping only on one side or the other. With the top drawing, we can now turn our attention to the legs. And here's one of the leg blanks right here. Now these I prepared ahead of time. What I did is I took 2 pieces of cherry that came out of the same board, so that way the color match would be as close as it possibly could be. I face jointed each one and then I glued it together to form these rough blanks. Now what I need to do is to run one side on the jointer in order to even up any discrepancy I have between the 2 edges, because no matter how careful I am, when I glue pieces together, they do shift just a little bit, and I want to take care of that. And the jointer is the perfect tool to do it. With that edge smooth and flat, I now want to make a 90-degree corner on here. So what I'll do is take the freshly jointed edge and put it up against the fence, because the fence is 90 degrees to the bed of the jointer. If I keep pressure pushing it sideways as I run it through, I'll get a 90-degree corner. With this corner perfectly 90 degrees and this edge straight, I want to take one jointed face, put it down on the table of the table saw, and the other jointed face up against the rib fence. What this will do is allow me to true up this face. Once this face is trued up, I'll rotate the blank 90 degrees and trim up the final face. I'm leaving it about 1/16 of an inch wider than I want, because then I'll run it through the jointer one last time to remove any burning left from the table saw. The legs need to be 28¼ inches long. First thing I need to do is square up one end right here on the radial arm saw. Now I can slide the leg down, and I put a clamp on the fence to act as a stop, so that way all the legs are cut the exact same length. The apron of the table is going to get attached to the legs using what's known as mortise and tenon joinery. This is the mortise. It's a rectangular hole cut into the leg into which the tenon will go. And once this is glued up, it is a very, very strong joint. The mortise can be tricky to make sometimes. You can do it by hand, which is time consuming. You can do it with a router, or you can do it with a mortising machine. A mortising machine really is nothing more than a special one-function drill press. It's not made to do a whole bunch of tasks. It only does one task, but it does it really, really well, and that is to cut mortises. The way it does that is through this. Now I have a bigger version to show you. This is a 1/2 inch chisel. This is a 3/8. That's what I'm using on the table, but for the purposes of demonstration, it's easier to see with the 1/2 inch chisel. It's really 2 pieces. You've got this special auger bit that has a single flute, and it's a very aggressive spiral. Its job is to remove the bulk of the material, and the aggressive spiral pulls the wood chips up and out of the mortise. The rest of the action is done by the chisel. It's a hollow chisel, hence the term hollow chisel mortiser, that is a square chisel into which the drill bit goes, and this thing cleans up the corners, because drill bits drill round holes, but you want a square mortise. This squares up the rest of it, and as it cuts away chips, it gets pulled up through here as well. So the mortiser, the motor on it spins the bit. You provide the power through the handle to push the chisel down. It has a depth stop and these little fingers. The depth stop limits how far down the chisel can go each time, so you get a uniform depth. And this is a little hold down, because when you go to pull the chisel back up, sometimes it tries to wedge itself in there, and this keeps the workpiece down as you retract the chisel. Let's go ahead and try making a mortise on this side of the leg. You'll notice I've laid out a start and a stop, and I'll work my way from one end to the other, skipping about the thickness of the chisel each time. Then I'll come back and do that. Right now this leg is 1 3/4 inches by 1 3/4 inches, and functionally that's perfectly fine. I could leave it like this and get a working table. But it just doesn't look that good being straight like this. It needs some sort of detail. And in this case, I'm going to taper it. So I marked a line 6.5 inches down from the top. That's where the taper is going to start. And then on the bottom, I marked a line over 1 1/8 inches, because that's how big the bottom of the leg's going to be. So I need to go from this line to this line with the table saw, and to do that I'm going to use this tapering jig. This tapering jig is pretty simple. It's just a couple pieces of straight wood with a regular door hinge on one end and this sliding bar that can be locked in any position, and it has a little foot to push the wood through. I also went ahead and added a couple strips of aluminum on the bottom just to keep this thing a bit straighter. To use it, what I need to do is take the leg, and I'm going to set it using the miter gauge on my saw, because the miter gauge on my saw is perfectly parallel to the saw blade. What I want to do is position it with the fixed side of the jig tight up against the fence and the pivoting side free to move. I want to line it up so that the start mark is right flush with the edge of the miter gauge slot, and I'll come back here and line this mark up with the miter gauge slot. And that's moved that one a little bit, so I will adjust it again. And after a little bit of fine tuning, I have the miter gauge slot touching this mark and that mark. So I can go ahead and lock in the jig. That gives me the correct angle. Now I need to set it the correct distance away from the blade. To do that, I'll take my fence and move it over. So that way the line just barely touches the blade right at that start mark. And because it's a circular blade, of course, I'm looking at the very bottom of the blade right there. Once I get it where it wants to be, I can lock it in place and we can make the cut. And just like that, it gives me a nice taper. Now what I can do is go ahead and taper the other side. And in order to not make a mistake and taper the wrong side, because traditionally table legs are tapered on the inside, all I need to remember is I always taper the side that has a mortise. So I just tapered this side, it has a mortise. If I turn it 90 degrees, I can now taper this side. Here's a mock-up of how the rails are going to work under the table. You'll notice it's got a 3-inch wide rail, and then it's got one of these little decorative brackets at each end. I thought about making this out of one big piece of cherry and cutting the little cutout out of it. The issue with that is this long rip right here. I want it to be nice and straight and smooth, and I was afraid the bandsaw wasn't going to give me that, and I'd be stuck with a whole bunch of sanding to try and make it smooth. So I took the easy way out. I'm actually going to attach these little decorative brackets to a 3-inch piece of cherry. And I'm hoping that the glue line won't be super noticeable. To make these little cutouts, the first thing I did is I took a scrap piece of cherry and made a little template and went ahead and traced it out. Now I can go over to the bandsaw and cut these out. I'm ready to sand the curves on these little decorative brackets. Normally I would use my drill press in combination with an appropriate sized sanding drum to sand the curves. But if you don't have a drill press, you can do it another way. These sorts of portable oscillating spindle sanders are available online from all sorts of different manufacturers. They're all essentially the exact same tool with a different color plastic and a different logo stuck to them. So I would suggest you shop around and get the best price, because as far as I can tell, there is no mechanical difference between one colored sander and the next. What's interesting about these is they are an oscillating spindle sander. So not only does the drum spin like on the drill press, it also moves up and down as it sands. That does a couple things. For one thing, you make better use of the sandpaper because it's using more of it than just the width of the wood. The other thing is it doesn't leave the swirl marks that a stationary spinning drum does, because the grains of sand are moving up and down, not just spinning in a circle. These are primarily designed to be used as a handheld tool to sand the edges of work pieces, and we'll be using this to sand the edges of the top of the table too. But the other thing it comes with is this little kit that has a rubber mat with a couple indents in it for the top of the tool. And then it has a couple of these special little clamps that go in a couple holes in the top of the tool. And then these can get clamped to the workbench. Top it all off, it also has a built-in dust port so you can plug in a shop vac and help keep some dust out of the air. Let's give it a shot and see how it does sanding some cherry. The brackets get attached to the rail with glue and biscuits. I've set up my table saw with the blade 3/16 of an inch above the table and an inch away from the rip fence in order to cut the shoulder cuts for the tenons on each end of the rail. And you'll notice that I'm doing this over on the table saw instead of one of the rail arm saws. While I normally like to do this operation on the rail arm saws, it requires referencing off both edges of the board, and that really isn't going to happen with this cutout right here. So what I'm going to do is use my miter gauge in conjunction with the rip fence. Now I can do that because this is not a through cut, so there's nothing to get wedged between the blade and the fence. If there was a cutoff that was going to be left there, I would need to do a different operation, but because there's nothing to get wedged here, I can do this. But like I was saying, I'm going to use the miter gauge in combination with the rip fence, pass it through once to make one shoulder cut. Then to make the other shoulder cut, as you can see, when I flip it over, the miter gauge isn't going to register here. So what I can do is simply flip the miter gauge around, and now I have a straight edge to reference against, and I can pass it through again. Let's try it out and see how it goes. Now I can use my tenoning jig as usual to cut the cheeks of the tenon. If I try the front rail in the correct mortise, it goes in with hand pressure and it's able to lift up the leg. However, it should be obvious it's not going to fit because it's too long. So what I need to do is trim it here and here so that way it can actually fit in the mortise. I'm going to do that right here in the bench vise using my little dovetail saw. Tabletop is going to get attached to the rails using pocket hole screws, and I drilled these holes using a regular pocket hole jig. However, there's one more step, and that is to account for changes in humidity. As the seasons change, the top is going to expand and contract slightly, and a standard pocket hole does not have enough movement in it to compensate for that, so the top could split over time. To get around that, now that I have the holes drilled like normal, I'm going to take another drill with an aircraft bit, and this is just a very long twist drill. I've chosen this one because it's twice the diameter of the screw shank. What I'm going to do is put it in one of the holes already drilled, and I'm going to try my best to line it up with the angle of the hole, and now I'm going to drill all the way through. And if you look, what that gives me is an oversized hole that when I put the pocket hole screw in, that now gives me plenty of room for seasonal movement. I'll just go ahead and drill out the rest of them, and then we're ready to glue this together. Now I can start putting it together. Now I can cut the top to length using my homemade panel cutter. Now it's time for the moment I've been dreading this entire time, and that is to cut a big hole in this new tabletop. First thing I want to do is drill a hole so I can start the blade of the jigsaw. The key to this operation is to stay on the inside of the line. Once I have it roughed out with the jigsaw, I'll come back in with a template and the router and clean it up. I've clamped the template to the top of the sewing machine table, and I'm going to use that in order to clean up these jigsawed edges. And to do that, I'm using a pattern routing bit in my router. A pattern routing bit is kind of like a flush trim bit, except the ball bearing is on the top of the bit instead of the bottom. Now, the length of this bit plus the thickness of the template makes it so I can't go all the way through in one pass. I'm going to have to route all the way around, then remove the template and complete the cut. Now with the template removed, I can let the bearing ride on the freshly routed surface, and I can clean up that little bit that's remaining. This table is getting breadboard ends on it, and to cut the grooves in the breadboard ends, I have set up the router table with a spiral bit, and I've set up these guide marks that will tell me where to plunge the breadboard end down in, and then when I get to the other end, where to remove it. The spiral bit is going to allow me to plunge down into this cherry a bit easier. And because it's cherry and it's going to put up a little bit of a fight, I'm only raising the router bit 1/4 of an inch at a time. So it'll take 4 passes to get to the full 1 inch depth. I need to cut the tongue on the end of the tabletop to receive the breadboard end, and to do that I'm using my router with a straight edge guide and a straight cutting bit. Now, as you can see, 1 pass was not enough to do the whole tongue. I'm not going to reset the straight edge, I'm just going to freehand this part. Drilled 3 holes for dowels to help hold the breadboard end in place, but I can't leave it just like that because this is going to expand and contract with changes in humidity, whereas this is not going to expand and contract. So what I need to do now is to elongate these 2 outer holes. The easiest way to do that is just take the drill and wiggle it back and forth a couple times. Before I reinstall the breadboard end, I'm going to glue the middle 4 or 5 inches. And what that'll do is lock the breadboard end in place so that way it doesn't shift around. Also, you'll notice I haven't enlarged that hole. That's going to stay the same size as before. Now I can slip the breadboard end into place, re-clamp it, and with a little bit of glue on the dowel, I can tap that down into place. For the end dowels, I want to put them in until they bottom out, put my thumb right there, pull them back out. That gives me an idea of the depth. What I want to do is just put a little bit of glue up near the top. That way it doesn't actually glue itself to the elongated hole. It's just gluing it to this tongue or this end, so that way it can still expand and contract, but the dowel won't fall out. Now I can go ahead and trim off the excess. The bottom edge is getting eased with part of a 1/4 inch round over bit. I'm ready to build the little shelf that's going to hold the sewing machine down in the recess. And the first thing I had to do was actually take the sewing machine that's going to live in this table and measure from the work surface of the sewing machine down to what it rests on. Once I had that distance, I could properly size these little drop downs. And to attach the drop downs, I'm going to use pocket hole screws. I'm not going to use any glue, so that way if there's ever a need for a different sewing machine to be put in here, I can simply unscrew it. And 4 pocket hole screws per little rail is going to be perfectly fine. Speaking of fine, because cherry is a hardwood, we want to use fine thread pocket hole screws, not the coarse thread that you would normally use with softwood or plywood. On top of that, because I really don't want to split this cherry, I'm actually going to go ahead and put just a little bit of paste wax on the tip of each one of these screws before I drive it in, just to reduce the chance of splitting. Now I can go ahead and screw on the shelf to hold the sewing machine. And now we just attached the top to the aprons using the pocket holes we drilled earlier. To finish this table, what I did is I used some boiled linseed oil, let that sit for about half an hour, and I came back with some de-waxed shellac. I put the shellac on, let it dry 20 minutes, and then I applied the first coat of wipe-on polyurethane. This is the second coat of wipe-on polyurethane. I'll give it 3 coats total, and then it'll be good for years of sewing.